So last thing we're going to look at still back of the book, Appendix 4, is complex numbers, how we multiply and divide them. Now, we don't know how to write, we only know how to write complex numbers like this. 2 plus 3i. That's kind of like writing the coordinate 2, 3. That's the rectangular way to write a complex number, which it's fine. You can add and subtract very, very easy that way. But multiplying and dividing, when you write complex numbers this way, is kind of it's annoying. Right? It's not super hard. It's just there's a lot of little steps you have to remember. If we knew how to write complex numbers in polar, we could do it multiplying and dividing a lot easier. So that's what section 5.3 part 2 is. We learn how to write complex numbers in polar so we can make what I'm going to show you a little easier. But I have to teach you all that stuff first and what I'm teaching right now, so we won't have enough time to get to the easier way to do it. So we're gonna look at just how you multiply and divide something like this. Okay, that's called rectangular. So one thing that's going to come up a lot is I squared. Okay, and we went through that yesterday. What's I squared equal to? 1. Not 1. Yep, that's I. I is the square root of -1. What's I squared? -1. Because if you take I and you square it, basically you're squaring a square root, so they cancel, and the only thing that's left is what's under the root. Right. So anytime you see a problem with I squared in the final answer, you're not done. Okay, so don't leave I squared in the final answer. On the test, there'll be multiple choice questions. I squared will be some of the choices. You can just cross that choice out right away. It's wrong. Okay? Don't leave I squared in the final answer. I just said it. Okay, so product of complex numbers, it's basically like foiling. Right? Not basically, it is foiling. So if you had two complex numbers, I'll show you guys what a problem will look like that, and you want to multiply them together, the way we're going to do it is double distributive property, where some people learn the word FOIL. FOIL stands for multiplying the first terms together, A and the C, the outer terms, that's the A and the DI, the inner, which is the C and the BI, and then the last. Now, the last is where you're going to get an I squared. BI times DI. Again, A, B, C, and D will all be numbers. So if it helps you, you can remember all the multiplications to do by remembering the FOIL, tell you which ones to do, or just think of it as the distributive property twice. Distribute A to both, distribute BI to both.
So what's BI times C?
Well, you'd have numbers for B and C, so it would be like 12i or something like that.
Just keep BI and then multiply.
Yeah.
Okay.
Yeah.
Makes sense.
So when you multiply A times C, you're going to get a real number. But A times DI and C times BI, those will be imaginaries. Like 12i and 6i, something like that. Okay, so let's look at this one. Now, when you look at it on the test, make sure you look at it carefully, which operation they're having you do. It's a huge difference if I write that, where I put a plus sign between them. Okay, huge, right? Plus sign, that's the kind of stuff we did yesterday. Okay. You don't have to do foiling with any of the stuff we did yesterday. You just combine like terms. Multiplying is when you got to FOIL. Okay, so let's go through all of them. So the first terms are 2 times 1. So how about Alyssa? When I do 2 times 1, what do I get? Yep, I get 2. Andrew, 2 times negative I?
2 negative 2i.
Negative 2I. Right, so that's the outer. Now we do the inner. Brianna, what's 1 times I? 1I. So you can put 1I, or just I, same thing. And Sebastian, let's do this next one in 2 steps. You have a positive times a negative. What's a positive times a negative? Negative. So we have negative. And what's I times I?
I squared.
I squared. Okay, so couple things we got to do. We'll keep this here for now. But Courtney, what's negative 2I plus 1I?
Negative I.
Negative I. Okay, so we just combine like terms. And Cal, the next part, we've got this negative I squared. What did we say I squared was?
Negative 1.
Negative 1. So we have negative, that just comes from right there. But don't write I squared. Put negative 1. Once you change I squared to negative 1, then you can usually combine it with something else. So 2 minus I, it's really plus 1, because it's minus 1. And 2 plus 1 is going to give me 3. There's your answer, and that's in standard form. Real part, plus or minus, imaginary part. You always want your answers to look like this today. Real, plus or minus, and then imaginary. In this case, in the first box would be 3, and in the second box would be like a negative 1. If it's a 1, you don't have to write it. You can just put the I. Great. Any questions on that?
Plus.
Bless you. Bless you. Thank you. You're welcome.
Let's try this one. Now, with the foiling, I showed every step there. You can combine some of the steps. If you can do it in your head, that's fine too. Okay, I'm not looking necessarily to show every single step. All right, Matt, what's the first 2 things I got to multiply here?
8 and 3.
8 and 3. And when I do that, Anthony, that gives me
24.
24. Okay, so we got that. Justin, what's the next one?
8, 9.
8 and I, so that's 8I. I'm not going to write it yet, I'm just going to remember it. 8I. And Gabe, what's the next one?
3i.
3I. So I'm going to write this down. What's 8I combined with 3I? 11I. So I just combined the 8I and the 3I all at once. Okay. Now the last one. I times I. Megan, what is I times I?
I squared.
I squared. And what's I squared?
Negative 1.
So I'm going to write that right away. Negative 1. Okay, so by doing it this way, I only have one more step and then I'm done. Because I did 2 of the steps in my head as I went. Emily, what's my final answer going to be here?
23 plus 1.
Yep, 23 plus 11. Good. That's it. Any questions on that? All right. So next thing we're kind of finishing up with now is we're going to get to division. But we can't do division until we know what that thing is. Conjugate. So suppose that you had a complex number. Okay, I'm just going to call it Z. Okay, some complex number called Z. Just give it a name. And it's A plus BI. Or maybe it's 2 plus 3i, or 6 plus 9i. That doesn't matter. You have a complex number. This symbol, Z, with a bar on top of it, is the symbol for what we call the conjugate. Still doesn't tell you what the conjugate is. I'm just showing you the symbol for it right now. So if you see a letter and you see a bar on top of it, it means they want a conjugate of this. To find the conjugate, very simple. all you have to do is if you had A plus BI, the conjugate is A minus BI. So all I did there was to change the sign of the imaginary part. Or a shorter way to say that is negate. Negate means make it the opposite of. So find the conjugate, leave the real part alone, don't do anything to the A, but change the sign or negate the imaginary part. Okay, so we're not even going to use that to do division yet. Okay, all I'm going to do now, we're going to practice. I'll give you a number, and I just want you to tell me the conjugate. Okay, so in the left column, I'm going to put a complex number, and then in the right column, I want to know the conjugate. Okay, so the first one is 3 plus 4i. What would be the conjugate of 3 plus 4i? More than 3 is part of it, but there's more. Yeah?
3 minus 4i.
3 minus 4i. Yep. How about the conjugate of -8 minus 2i?
It's like absolute.
You're not doing anything to half of it, so. And it's not always going to come out positive when you write the conjugate. It can be negative. So
So is it literally just flipping the signs?
yeah. Well,
So it's just flipping the sign of the I?
Of what's before the I.
Yeah.
so the next one would be what?
-8 plus
So if we use
-8 plus 2i.
Okay.
So you're just changing the sign of the imaginary part. How about 5i? Yeah, I feel like that one seems a little different. Just think of it like this. You don't have a real part, so think of the real part as 0 plus 5i. Okay? The conjugate is 0 minus 5i. You're not going to see 0 plus. They don't write it that way. How about 3? 3. The reason that one stays the same is because there's no imaginary part on this number. So think of it like this. 3 plus 0i. The conjugate is 3 minus 0i. Same thing. Plus 0 minus 0. Okay. So that's how we find conjugates. Now, I'm going to give you a complex number, and I want to multiply it by its conjugate and see what happens. There's the complex number, 3 minus 4i. So, if I want you to multiply by the conjugate, that's the first step. What's the conjugate of 3 minus 4i? 3 plus 4i. And now we're going to multiply those two things together. So now it's just like the problems we did in example 1 and 2. Except now we're multiplying two special things. We're multiplying conjugates. So let's see what happens. So Abigail, when I start off, what's 3 times 3? 9. And Riley, 3 times 4i?
12i.
12i. So we got that. Now we're going to go to the inner. Madison, what's the product of the inner?
Minus 12i.
Minus 12i. And now we're going to do the last. So Alex, first, what's a negative times a positive? It's a negative. 4 times 4?
16.
16. And we still have the I times the I.
So I squared.
I squared. Okay. What's going to happen when I combine 12i and a negative 12i? It cancels out. Anytime you multiply conjugates, that's going to happen. So it's a waste of time to do the outer and the inner. You don't need to. They're always going to cancel out. All you really have to do is the first and the last. So we got the first minus. Now we don't want to leave I squared. What did we say I squared was? -1. you're subtracting negative 16. So that's really 9 minus negative 16. Write it like that if it helps.
9 plus 6.
So it's really 9 plus 16, or 25. So what do you notice about the answer?
Only one number.
And what kind of number is it? It's real. Anytime you multiply two conjugates together, all the i's are going to cancel out, and you're just going to get a regular number. Okay. And there's a quicker way to get that number than actually foiling, okay, with conjugates. All you have to do is look at the first number and ask yourself, okay, what's 3 squared? 9. Okay. Take the other number. Doesn't matter if it's positive 4, negative 4. Doesn't matter. What's 4 squared? 16. And then you add those up and you get 25. If you said, well, should I do the negative with the 4? It doesn't matter. Negative 4 squared is still 16. Just take the number you see here, take the number you see here, square them, and then add them up, and that's the answer. So, let's try this one. I don't want to FOIL it though. Let's use the shortcut. My first number is what? Square it, which is 25. Second number?
16.
Negative 4, 4, doesn't matter which one you pick. Take that 4, square it, you get 16. And add them up, what's your answer? 41. So if you were to FOIL all of that out, you'd get 41. You'd waste your time with the outer and the inner, because they would just cancel. And then you'd get the I squared and deal with all that stuff. Okay? You don't have to use this trick if it messes you up. Just go and FOIL it out every time. But if you FOIL it, you will get 41. Any question on that?
Does the trick work every time?
With conjugates, yeah. If you don't have conjugates, you just got 2 random numbers you're multiplying, you just got to do it out. There's no trick. But yeah, somebody said, what's 8 plus 2i? 8 minus 2i? And I should be able to do that in under 10 seconds. 8 squared is 64. 2 squared is 4. The answer is 68. That's how you do it. Okay, so now we know what conjugates are. We've got a shortcut for multiplying conjugates, if you want to use it. So now where the conjugate comes in handy is when we divide. So the problem with dividing is if you have a problem like that, you're never allowed to leave i's in the denominator. So we have to have a way to make all the i's cancel out and disappear. We do. Conjugate. Whenever you multiply conjugates together, all the i's cancel out. And that's where we're going to use it. So, to divide two complex numbers, we actually do multiplication. That's how you do it. You take your problem, and you multiply the top and the bottom of your problem by the conjugate of the denominator. So to divide two complex numbers, multiply the top and the bottom of your problem by the conjugate of what's in the bottom. Now, example 5 is a little bit easier than example 6 because if you look at example 5, the numerator is pretty simple. Right? That's going to be an easier problem to do. When we do example 6, the numerator is a little more complicated. Still the same method though. Multiply the top and the bottom by the conjugate of what's in the bottom. And I always put everything in parentheses, just so I remember that it's distributive. Okay. So on the right, I've got the fraction in green. What's going to go in the parentheses? I'm going to multiply the top and the bottom by what? Yeah.
3 minus 4i.
3 minus 4i. Any questions why we're using 3 minus 4i? Okay, now the top is really easy. We haven't even really done one this easy, but all you have to do is the simple version of the distributive property. Just take the number on the outside and multiply it to each number on the inside. Obviously, when it's 1, nothing's going to happen. So 1 times 3 is 3. 1 times negative 4i is still negative 4i. Right. Now, the bottom, even though it's the more complicated distributive property, you don't really have to do it that way because they're conjugates. So all I have to do is take 2 numbers, square them, add them up. Yeah, 3 squared is 9. 4 squared is, thinking ahead, 4 squared is 16. Add 9 and 16, you get 25. Now, look at that answer. Does that look like, let's go wherever I had it, like that. Real part plus or minus imaginary part. No, not quite. Right? You're not supposed to have a fraction like that in the final answer. So the way you have to write that is like this. There's the real part, 3 over 25, minus, because it's minus, 4 over 25. So the real part is 3/25, the imaginary part is negative 4/25. And we just put the I right next to the number. You can leave the I in the top, but we usually put it right in the middle like that. And that's the answer when you divide that by that. Any questions on that? Okay, so a little bit easier on this one because the number in the top was just a 1. Now the number in the top is a complex number. So you still do the same thing, but you are going to have to FOIL in the top. Now, since you got 2 complex numbers, you got to make sure you know which one you're using. We're using the conjugate of the denominator. So the conjugate is going to be what? Yeah. 5 plus 12i. Now, I usually do the bottom first because those are conjugates, so it's quick. What's 5 squared? 20. And 12 squared? So once we add those up, the bottom's done. Okay, now, are the top numbers conjugates? No. Then we just got to FOIL it all out. Okay, so let's just do it all out. Okay, so Pat, 1 times 5 is going to give me 5. And Elizabeth, 1 times 12i?
12i.
I'm just going to put that off to the side for a second. 12i. And your Shira for 4i times 5. 20i. That's a 12i and a 20i, which is how much? 32i. All right, now let's see if we can do this last part all at once. Positive 4 times positive 12. What's that? 48. And what's next to it? I squared. So what number is it really? It's really negative 48. It's 48i squared, which is minus 48. Okay, so now combine what you can in the top, in the bottom, and then we'll separate it into two fractions. 5 minus 48 is going to give me how much? Negative 43. Plus 32i. And 144 plus 25.
169.
169. Last step is just to separate that into two fractions. So the real part is negative 43 over 169. Imaginary part, 32 over 169. Now, let's say the real part, I'm just going to make up a number, came out to like 2 over 4. You can reduce it. You always reduce it like if you can. Okay? But I don't, you could check on your calculator, but 43 and 169, that doesn't reduce. Okay, so any questions on dividing? Yeah.
Will we lose points if we don't use?
If it was a short answer, probably take off 1 point for not reducing. If it's multiple choice, then you wouldn't see an answer listed that's not reduced. So you'd have to be able to match up your answer. Okay. Any other questions on this one? Okay. So last thing we're gonna look at is a little bit of 5.3 part 1. First thing they show in 5.3 part 1, very, very simple. It's called the complex plane. The name of it is complex, it's not that complex. It's kind of like an XY axis. But instead of calling it the x-axis and the y-axis, they call it the real and the imaginary. So what this allows us to do, bless you, is be able to graph complex numbers. If you can graph the point 2 comma 3, then you should be able to graph the point 2 plus 3i. It's the same answer. You do the same thing. So you look at the 2. Okay. Is 2 real or imaginary? Real. So we're going to go 2 units on the real, and the units are the same direction as what you're used to. Right and up are positive, left and down are negative. So 2 units on the positive, so 2 to the right on the real. And what's the imaginary part here? 3. Is it positive or negative? Positive. So it means 3 up. So 2, 3. That's the point 2 plus 3i. That's how you graph. The biggest mistake I see people make is they switch the real and imaginary axis. They'll put I down here and R up there, and then it's wrong. Okay, so real horizontal, I vertical. Okay. Jason, what's my real part there?
4.
4? Positive or negative?
Positive.
Positive. So we're going to go 4 to the right. And then my imaginary part. Do you want to finish that one up?
Negative 8.
So negative 8 is
Negative. So down.
down. So right 4, down 8. Stephen, how about this one? Negative 8.
Negative 8, so that's left 8.
Left 8. And how about up and down?
0.
0. It's negative 8 plus 0i. There's no up and down. And then how about 5i? Which way would I go to 5i?
Up 5.
Up 5. What about left and right?
Just there.
Stay right there. Okay. So just like graphing points, they can be in a quadrant, they can be on an axis. That's how you graph. Any questions on that? You'll probably have 2 of those on the test. Okay, I'll just give you 2 coordinates and just have you graph. Okay, so pretty straightforward. Okay, last thing. So this is the thing that we would have done a little bit today and a little bit tomorrow. Instead of writing complex numbers like this, that's rectangular form. I've already told you what rectangular form is good for. If you want to add and subtract complex numbers, there's no simpler way to do it than the way we learned yesterday. Just do it like that. If you want to multiply and divide, all this stuff we did, this is not the best way to do it. There's a better way, faster way, easier way. But the easier way to multiply and divide complex numbers means you have to know how to write complex numbers in polar. So this is the start of the connection between what we learned about polar on Monday or Tuesday, and then what we learned about complex numbers yesterday. So let's suppose that we had a complex number. Again, I'm just going to call it Z. I usually use the letter Z a lot for complex numbers. I don't know why, they just do. And I have the real part plus the imaginary part. Now, if you're looking at that, you might be saying, well, shouldn't I do it like this? Don't we usually put the I after? Yeah, we do, but I'm trying to match it up with what the book does. And for the formula that we're going to come up with, they put the I before. It really doesn't matter. 3I, I3, it's the same thing. Right, but this is going to match what the book does. Right, that's rectangular form. 2 plus 3I. 8 minus 6I. Real part plus or minus imaginary part. Now, what we're going to do is we're going to take that and we're going to change it to polar. Just like when we deal with regular numbers in polar, we don't have an x and a y anymore. What are the two things that you have when you write something in polar? It's not x and y, it's
Radius and angle.
radius and angle. And those are the same two things we have to find here. We're just going to find a radius and an angle of a complex number. Okay, that's all. So, we have to get rid of the x and the y. If you're going to write something in polar, you're not allowed to have an x or a y. But from Monday or Tuesday, we already have a formula to get rid of the x and the y. Does anybody remember what the formula for x was? Please?
R cosine angle.
Yep. So there's your formula for x. That's going to get plugged in right there. What about our formula for y? R sine theta. R sine theta. That's going to get plugged in right there. Leave the I alone. The I is going to stay right where it is. So we're using the same two formulas we already know from Monday. So I have that. Actually, now I have to write it. So x is r cosine theta plus, keep the I right where it is, and then fill in y, r sine theta. Now, if you look at what I just wrote in green, in front of each trig function, they both have what letter in common? R. Whenever we have the same thing in common, in math, we usually don't like to write it more than we need to. If you have the same thing in common, you can factor it out like this. If you factor r out of the first part, what's the only thing you're left with? Cosine theta. If you factor r out of the second part, what are you left with? I sine theta. That is the polar form of a complex number. It's r in parentheses cosine theta plus I sine theta. So, just like polar with real numbers, there's two things you have to find. You need to find r, that's your radius, and you need to find theta. It's the same in both. That's your angle. Well, yesterday we learned how to do that. Okay? The radius, we use the Pythagorean theorem. X squared plus y squared equals r squared. Same formula you already know. And to find the angle, does anyone remember what trig function we used? It was inverse tangent. We're going to use the same formulas again. So I'm not going to rewrite them all. But all the same rules apply. If you're in quadrants 1 and 4, inverse tangent y over x. If you're in quadrants 2 and 3, it's still inverse tangent of y over x, but what do you have to add to it?
180.
Yep, good job. You got to add 180, or pi, if you're doing radians. Okay, so all the formulas you already know still work for this. You don't have to use any new formulas. So let me show you what a final answer would look like. I'm just going to make up something. This is a final answer to a problem. 2 cosine 15 degrees plus I sine 15 degrees. That's it. That's a final answer. Don't do anything else to it. That's the final answer when we do a problem. If you said, well, should I just take the cosine of 15 on my calculator and then do the distributive property times 2? No. If you do that, you're going to be changing the problem back to what you started with. You're going to be undoing everything you just did. Right? I guess if you had time and you wanted to check it, you could do it out, but you don't have to. You stop right there. Okay, so we'll do this one and we'll check it. Okay, so they want us to write this in polar. Okay, first thing, I want to make sure we know what number is in front of I because they didn't write one this time. That's a negative what?
Yeah.
Yes. We have a -1 right there. It's not necessary to write it, but if you want to put it in, you can. Okay, so we got to find two things, R and theta. Let's start with R. Now, this is where the graphing kind of comes in handy. The real axis is taking the place of which letter? X. So when you think real, think X. Real, X. The imaginary is taking the place of what other letter?
Y.
Y. So when you see imaginary, think Y. Okay, I'm just going to write that right here. X, or actually I think I said it this way. Real, think X. Imaginary, think Y. Square root of 3. Is that real or imaginary? That's real. That's my X. -1. Real or imaginary? It's imaginary because it has an I next to it. That's my Y. It's also right in alphabetical order. X, then Y. Any question on why this is X and why this is Y? Okay. So now we fill it in. Someone remind me, what's the formula? R squared equals X squared plus Y squared. We don't even have to do it out yet. X squared plus Y squared. The I is not part of it. X is a number, Y is a number. When you're doing out the radius, don't include I. Just the X, just the Y. Okay. What's the square root of 3 squared? 3. What's -1 squared? 1. So that gives me 4. And now we take the square root, so my radius is 2. Okay. So now when I write my final answer, I got my radius. What's the one other thing I need? I need the angle. Now, we have two different formulas for the angle. Right? It depends on what? Where it is, which quadrant it's in. So let's look at this point. Now, this is why I taught you how to graph something like this. You have to be able to look at that point and tell me which quadrant it would be in. Where would square root of 3 -1 be? Which quadrant? 4. Positive, negative. Somewhere right around there. Okay. What's the formula for theta if I'm in the 4th quadrant? Do I add 180? No, not in quadrant 4. Inverse tangent of, now look at what y and x are. Y over, what's x? No, square root of 3. Okay, let's type that in and see what we get. So I'm going to switch over to degrees. I'm going to do second inverse tangent of -1 divided by square root of 3. Okay. So we get an angle of -30. There's nothing wrong with -30. That answer is correct. But what can you add to it if they said make the answer positive? You can add 360. If you add 360 to -30, what do you get?
330.
330. Yeah. Both of those answers are correct. I just feel like going with a positive radius and a positive angle. It's how I feel right now. So, final answer. Let's look at the format again. R cosine theta plus I sine theta. Just fill in those 3 spots. R cosine theta plus I sine, and then fill in theta. And that's it. That's the final answer. Don't do that out. Okay? If you did, watch what happens. I'll do the second part. Let me take 2 distributed times the sine of 330. Watch what you get. 2 times the sine of 330. I get -1. That's exactly what I started with. So if you do it out, you're changing it back to what you started with. Right? If I did 2 times the cosine of 330 and distributed it out, I would get square root of 3. So if you do that out, you're changing it back. So leave it just like that. And that's how you write a complex number in polar. Okay, pretty much exactly the same amount of work you had to do when we did this with real numbers. Pythagorean theorem and inverse tangent. You're just writing your answer a little different, but it's the same amount of work. Any questions on that? Okay, I didn't have a second one of that, but does anyone feel they need to see a second? You'll probably have 2 or 3 of those on the test. Anyone feel they want to see a second one? Like one that's maybe in quadrant 2. All right, we'll do a quick one in quadrant 2, and you still have like 20 minutes left. You know what? I'll let somebody make one up. Somebody give me a coordinate that would be in quadrant 2.
-4, -2.
That's quadrant 3, but we can go with that. It's okay.
It'll still work.
You still have to add 180 to get the angle. That's fine. It's not going to be a nice angle though, so we're going to round this off. So there's your point, right in polar. R squared equals. Let's fill that in. What's going to go in the first parenthesis? And Courtney, what's going to go in the second parenthesis?
2i. -2i. -2.
Yeah. Just -2. No letters.
No letters.
What's 4 squared? -4 squared. Doesn't matter. 16. -2 squared. 4. Actually, this is a good one because watch what happens here. We get 20. R is the square root of 20. But what is the square root of 20 if we simplify it? 2 square roots of 5. That could happen. Didn't happen in the last problem, but it did happen here. So there's your radius. Done with that. Okay, now we have to find the angle. What quadrant is that in? Isaiah? That's quadrant 3. Left and down, quadrant 3. When we're in quadrant 3, do we have to add 180? Yes. If you forgot to, then you're wrong. So make sure you add 180. 180 plus inverse tangent. What goes on the top? Y, which is -2 divided by, yep. When I do that on my calculator, I'm just going to do inverse tangent of 0.5 because -2 over -4 is just 0.5. All right. Okay. So let's see what we get. Inverse tangent of 0.5. And now I'm going to add 180. I could have typed it all in at once. Doesn't matter. 206.57. 206.57. Okay, there's your angle. There's your radius. It's kind of weird to write one exact and one as a decimal. Usually you either do both of them as decimals or both of them exact. But we'll go living on the edge. All right. So the radius is 2 square roots of 5. And what comes first inside the parentheses? Cosine. Then the angle. What is it? 206.57. Plus, and what comes next? I, then sine. And what's it going to be? Sine of the angle. 206.57. Now, if you checked this one by distributing it back out, you probably wouldn't get -4 and -2. Probably get like -3.999 and -1.999. That's because this number we rounded. So yeah, that's good. Any questions about that? Okay. So homework tonight on 560. That's the multiplying and dividing complex numbers. Page 333. That's the graphing complex numbers and then writing complex numbers in polar. Okay, don't forget I will be after school today till probably maybe a little before 3:30 if you need help with anything. Also, no one's come to me with any questions about their grades, so I'm assuming everybody is checked it and it's fine, or you don't really care, or whatever. But if you do have questions or you notice something's not right, today would pretty much be it, because I think you're going to get your report card tomorrow. Yeah, you're going to get it tomorrow.